I'm Tim Merrill. I work for BC Machining. I manage the shop floor, managing the employees, and complete most of the setups out on the shop floor as well.
And I'm Mike Driscoll. I'm the manufacturing engineer for BC Machining, and I do all the CNC programming, keeping up with tooling inventory, making sure that information on the floor is correct, and that's mostly it.
Previous to using MachineMetrics, we didn't have a reliable way to monitor what was happening at the machines. Since implementing MachineMetrics, it's extremely easy to source the information that we're looking for related to the machines. And it makes our process for relaying it to our operators and catching our issues is probably improved by about 90%. If the information is presented to you, you don't have to go hunt for it now that we have MachineMetrics implemented. When we started using MachineMetrics, it solved a lot of our problems. It also introduced a couple of its own issues. One of those is being the tracking and the logging by our operators and by our setup people. To have the correct information implemented in the machine at all times. We've had a couple instances where we've had an incorrect job called up. It just takes a little bit more due diligence on our operators' part and just a new kind of cultural philosophy to get everybody on board and have everybody aware and doing that consistently. And that did take a little bit to implement.
And it's only as good as the information you put into it. So originally it helped us to track scrap and downtimes and inefficiencies in our process. Once we implemented MachineMetrics, we can still track scrap as long as operators are putting it in, and we can still try to pinpoint inefficiencies and downtime as long as operators are recording the reason for the downtime.
As a shop, every bit of scrap we produce is, a detriment to us. So our scrap, we are always looking to reduce our scrap rate. MachineMetrics really helps us track it. We can see the specific operator that tracked it, and we can also make sure that it's being tracked. To do that, we see what was entered into MachineMetrics, and then we compare it to the physical parts that we have. It lets us know what operator did it, and lets us know if we have a problem operator or if we have a problem process. Our star machines, they're our Swiss turn machines. They had a problem where they would break a tool and they would continue to run because they're an automated process. MachineMetrics was able to do a predictive tool breakage for us, and that has eliminated all scrap coming off of that machine. Before, it would take an operator to walk over to it on his own accord and visually verify that the tool hadn't failed. And now currently we're in a situation where 100% of the time the tool detection has caught the tool on its first failure. Okay. Since we've started using the predictive tool break technology, we have seen our scrap rate reduce considerably. Our operators don't have to go over and tend to the machine at specific intervals of time. They only need to go to the machine when we've had a downtime reason, which they'll see on our MachineMetrics screen or from the add-on light at the machine. It's made it so our operators can spend much more time at other machines, focusing on parts that need to be produced rather than checking on a part to see whether it's still good or whether it's not good. So it's had a drastic impact on our shop floor and where our operators need to be and where their attention needs to be focused. One of the unintended consequences that we've seen from using the predictive tool failure method is before, when our tool would fail, it would continue to produce scrap parts and they would be mixed in with our good parts, and we batched them out several hundred at a time. before we would have to go through and manually sort all 100% of those parts for the tool failure. Now that we don't have bad parts being mixed in with our good parts, it is 100% eliminated our need to sort for tool failures.
So before we were using the predictive tool technology, our operators would have to walk to the machine at least once an hour and make sure the parts coming off are good. In the past, when you'd have a broken tool, you'd walk over there and you're kind of annoyed immediately because now you have to sort through all the parts to find the bad ones. And then you have to go into the machine and change the tool out and get it running again. And we had some instances in the past where we'd have a breakage right after we put a new tool in. So there's times where you'd have to change that out and do that whole process throughout an entire hour. And now, since we're using the predictive tool breakage technology, you get a notification on the screens or at the machine or on your phone that says, hey, the end mill's broken. So you go over there, you spend about 5 minutes, you replace the end mill, and the machine's back up and running. And you might have lost a total of 7 to 10 minutes. And the operator's back at the other machine, keeping production running.
Previously, on a worst case scenario tool breakage, we would get, I think our worst was 2 to 3 hours worth of the machine running, producing scrap parts. We also now have the opportunity that we will allow the machine to run when we leave. And we run 3 shifts now, so we don't use that much, but we can leave now with confidence knowing we're not going to continually produce bad parts, that if we start to produce bad parts, the machine's going to stop as well.
Okay, the longest portion of the whole thing was running the cable, the Cat5 cable. You know, we just bought a big 500-foot roll, put our own ends on, but we probably spent, it was a whole lot more time just running cable. Once we plugged into the machine, I don't think it was 5 minutes and we were up and running.
Wow, you said 5 minutes?
Yeah, it's, you know, once the cable was into the focus, we didn't really have any problems at all. You know, setting the control up, you sent the directions on how to, you know, what we needed to change in the control in order to communicate with the focus, and it went superb. I mean, no problem at all, not one. So to go back to the question of, you know, where did we spend the time? We spent the time mainly running the cable. You know, that was something that wasn't supplied by MachineMetrics. After that, we once we plugged them all in, you know, we bought that. Excuse me, Graham, I'm going to forget the name, what you call it, but I think it's the Edge device. But, you know, what we plugged everything into in order for it to communicate to you. Yeah, so we went from running the cable from the machine to a router, not a router, I guess a switch, basically, yeah, really. So we went to a switch and then into that your system. And once we had everything plugged in, we literally, they had a little 1-page sheet of instructions on how to set the focus up. We went through that. There's a cat in here, sorry. We went through that, and again, 1 page, easy document, very easy to get through. So again, 5 minutes, plugged everything in, and we were able to communicate. And the same thing with the tablets. They basically come ready. You plug it in, set up your Wi-Fi protocol, and it's all good. You know, it was good to go right from the beginning. So very, very simple, very easy, and very quick. Immediately, you know, we had the tablets immediately. The one thing that I had to do was that we wanted to do anyway was put the big screen TVs hanging on the walls in the shop so that we could get that whole, you know, see all the current little boxes for each machine. So, you know, that that took a little bit of figuring, but you know, we used a Google Chrome stick and a cordless keyboard. And can you still see us? Because we're getting a low battery warning on this phone.
We just lost the video. Yep, we're back.
Okay.
Okay.
So we were able then, using the Google Chrome, to connect that into the Wi-Fi to go to MachineMetrics, and we have our screens showing. Yeah, we probably spent, what, 2 days running the cable. Mike helped me with that. We spent 2 days running the cable. And then I would say, to go around to every machine, it was certainly less than one more day to have 10 machines communicating and working properly.
Since using the predictive tool breakage technology with MachineMetrics, our time savings at our Swiss turn machines has been monumental, to say the least. We've gone from potentially losing maybe a third of our shift's worth of parts, and then spending 30 minutes to an hour sorting through parts and finding the good ones from the bad ones, to now we're not wasting any time sorting through parts to find a good or a bad part. We're not losing time that the machine's running and not making good parts. So for the most part, when our machines are running, we're being profitable because we're not making bad parts. So with using the predictive tool breakage technology, there is some false alarms, I guess you could call it. We've had maybe once a week, maybe twice a week, we'll probably get an alarm for broken end mill, and it won't be broken. When that happens, we keep a pretty close eye on the next couple parts just to make sure the tool didn't crack or something, and it'll fail soon. But it's not that common considering the amount of parts we're making off of that machine in a day. Also, I think maybe 2 or 3 times in the last 3 or so months, there hasn't been an alarm when the tool immediately broke. It might have alarmed out in the range of 5 to 15 parts later, but it's more rare for it not to catch it than it is to catch it and it not actually be broken.
The reason I kind of let Mike answer this question, I have a little bit of trouble answering this question because I feel like it's near 100% of the time, but all the time, the times where we've had slight issues with it is, I feel like it's when we've done the testing on it, and that's when I'm involved in it more. These machines kind of run in the background, and I don't want to say I ignore them, but I ignore them until I have an issue with them. So like I said, I feel like it works extremely good. I would feel comfortable putting near 100% number on that. Like I said, there's been a couple little test things that we've done where it seemed like it maybe didn't work quite as good for just like very short portions of time.
Yeah, like it's way more common for it to give an alarm that didn't, the end mill broke when it actually didn't. That's, you know, I mean, it's common, not even common, but it's not a problem because you just go and reset the machine. And there's probably literally only a handful of times since we've ever started it that it didn't catch it in the first part or 2 parts. And that's only because we had one recently that I can remember. But before that, it's not. I mean, like Tim said, it's probably almost 100% of the time it's catching the end mill when it breaks. And maybe 6% of the time it's going to give you a false alarm. But I'd rather have a false alarm than no alarm.
And, you know, with the false alarm, if the guy comes up to me and he's like, hey, you know, it said it broke the end mill, but it didn't break it, and that happens once every other week,
yeah,
I'm going to forget that it even happened. Personally, for me, I just got a lot of other things kind of going on.
And it's not a big deal.
So, you know, I'd feel comfortable answering this question at 95% if you'd like me to answer it like that. I feel like it's probably, I feel like you do even better than that, but I'm a little cautious to say 100% of the time,
Yeah.
all the time. I know I did in several of my other answers, but one of the things that I hope MachineMetrics is able to do with the predictive tool failures in the future is have a load detected on initial setup, and then have a parameter where we say if we reach X amount more of load than where we are currently, that we're going to stop the machine so the tool can be inspected at that point. And I think that's something that MachineMetrics could do, and I think it's something that I'd like to see in the future. MachineMetrics has been great to work with because they are continually improving. When we started out with them originally, there was no predictive tool failure. We have that now. It's worked well, and they've actually improved the algorithm since we've started originally with that. That seems to be a trend with MachineMetrics where they're continually improving their processes and methods.